Hi all, today we're going to be doing a problem from the AIME Math Competition, question 12, year 2016. The question states, the figure shows a ring made of 6 sections which you are to paint. You have 4 colors available and you will paint each of the 6 sections a solid color. Find the number of ways you can choose to paint the sections if no 2 adjacent sections can be painted with the same color. Okay, so let's just tackle this question head on. So let f of n be the number of ways to color n sections. And I have these 4 colors here, C1, C2, C3, C4. So let's imagine that we have this ring and we haven't colored it at all. It's basically colorless right now. And for the first section over here, I've called it section 1. How many colors can I place? Well, I can place 4 here. And for the next one, since there's 4 colors and in this section none of the colors can overlap those from this section. So for example, if I have C1 here, then on the second section I can have C2, C3, or C4, not C1. So over here I can always have 3 colors, and the same logic applies for all the rest. So I can have 3 here, 3 here, 3 here, and finally 3 here. Now once we get to the 6 sections, there's a major problem here. We're saying that at the 6th section, we'll always have 3 colors available, and that'll give us a valid arrangement. However, that's wrong. For example, if I have the color C2 at the 5th section, then at the 6th section, I can only have C3 and C4. But according to our previous selection, we can also have C1. And this is wrong, and so what in fact we have to do is we find the total number of ways to arrange it in which the first section and the last section can overlap, and then we have to subtract the ways in which the first section and last section have the same color. So we have that f of n equals 4 times 3 times 3 times 3, and since there's n minus 1 3's, this basically becomes 4 into 3 raised to n minus 1. And what exactly do we have to subtract here? Now, if the first section and the last section have the same color, we can basically remove the boundary between them. In order to find the number of ways in which we can have the same color, we can remove the boundary between them. And what we'll end up with is, in this case, we'll end up with 5 sections. And now, how do we find the number of ways in which we can have 5 sections which are valid arrangements? Well, we can just do the same thing. In this case, we can remove this boundary. We can remove that boundary, and we end up this time with 4 sections. And so we'll keep on going until finally we come to the case where n equals 2. And therefore, in general, f of n equals 4 times 3 raised to n minus 1 minus f of n minus 1, because f of n minus 1 is the number of ways in which the first section and the last section will have the same color. There's one thing that we have to clarify. F of n equals 4 times 3 raised to n minus 1 minus f of n minus 1. This expression is only valid for n greater than or equal to 3. And the reason for that is, suppose I have a circle here, and suppose I have this circle here, and then I have only 2 sections. So only 2 sections here, right? So I'm saying that I can color this guy in 4 ways, and I can color this guy in 3 ways. And this is absolutely fine. There's no way that these two sections can overlap in color. If we color the first one in, say, C1, then we'll always have 3 other valid colors, C2, C3, C4, to color this one with. And so we've proven now that f of n equals 4 times 3 raised to n minus 1 minus f of n minus 1 for n greater than or equal to 3. And since we want to find out the number of ways we can color 6 sections, so we have to find out f of 6. So f of 6 equals 4 times 3 raised to 5 minus f of 5, and f of 5 equals 4 times 3 raised to 4 minus f of 4, f of 4 equals 4 times 3 raised to 3 minus f of 3. And finally, f of 3 equals 4 times 3 raised to 2 minus f of 2. And now, since we can't evaluate f of 2 by this expression, we have to calculate it manually, and it was pretty obvious what f of 2 was. Basically, you've got these two sections over here, and you can color this one in 4 ways, this one in 3 ways, so that's 4 times 3, that gives us 12 ways. So I have 4 times 3 squared minus 12. And now, basically, all you have to do is substitute this f of 3 in here, this f of 4 in here, and this f of 5 in here, and you'll get f of 6. And f of 6 comes out to be exactly 732. Anyway, this was the solution. I hope you enjoyed the video. Have a nice day.